Okay, so welcome again to the KTU question paper solutions of advanced manufacturing technology. This is from May 2019 question paper. And the question is, what are the different methods of atomization for making metal powders in powder metallurgy? What are the various methods, different methods of atomization for making metal powders in powder metallurgy? Different methods are there. Different methods of atomization for making metal powders in powder metallurgy. And here you can see the marks is actually 6 marks. Okay. So when you write this marks is very important. Okay, you have to, whenever you write write the answer, you have to check this marks. So here you can see 6 marks. So what are the different methods? So you have to explain the different methods only. Okay, what are the different methods of atomization with the help of figures? So you have to draw the figure very neatly, and then you have to explain this very minimum. Okay, that is very important. Okay, you have to explain this different methods of atomization with the help of figures. You have to draw the figure, neat figure. Okay, so I will share my file. Okay, so first of all, atomization means the powder production method. So the first step in powder metallurgy is to produce the powder, fine powder. So the first step in powder metallurgy is powder production method, and atomization is the most common method for the preparation of powder. Nearly 80% of the total volume of powders is prepared with the help of this atomization. So here the molten metal is converted into fine spray of droplets, and that will solidifies into smaller particles to form a powder. Any material that can be melted, and we can convert that into powder form. That is the atomization. That is the definition of atomization. Okay, this is the most versatile, most popular and versatile method available for manufacturing of the metal powders. This is the most popular and versatile method among all other methods. And gas atomization is the first type of atomization. Gas atomization means here high velocity gas is there. So here in this picture you can see the important components. This is the gas with expansion nozzle, and you can see the siphon. Here in the bottom you can see the molten metal, and here in the right side you can see the collection chamber. In this collection chamber we will collect the metal powder. So here high velocity stream of gas is used to convert the liquid metal into fine spray. So here this high velocity stream of gas is used to convert this molten metal into this fine spray. The air or inert gas is allowed to flow through an expansion nozzle. So here this is the expansion nozzle, and the air or inert gas is allowed to flow through the expansion nozzle, which siphons the liquid metal from the crucible below. As the liquid metal comes up, this liquid metal is carried away by this high pressure gas, and this liquid metal is sprayed into the container. And this, because of this spraying process, this creates this tiny droplet. So here this dotted line represents the tiny droplets of metal, and this will solidify and into powder form, and this powder will be collected into the collection chamber. The similar process here, this is the similar process. Here, this molten metal reaches to the gas nozzle by way of gravity. So here in the top, you can see the molten metal, and this molten metal which reaches to the gas nozzle by way of gravity. So here in both sides, you can see a gas, you can see a term gas with an arrow. So this represents the gas. This represents the gas nozzle. Here this molten metal reaches to the gas nozzle by way of gravity, and this gas or air jets immediately whenever this molten metal is in contact with this air or gas jet, this will immediately atomize the liquid. This will immediately atomize the liquid and to form nearly spherical droplets of the liquid metal. So here in gas atomization, the shape of the droplet will be spherical in shape, spherical droplets of the liquid metal. And this spherical droplets cool down to solid powder particles, and that will be collected in the collection chamber. This powder particles will be collected in the collection chamber. And the process variables are the jet distance, jet pressure, nozzle geometry, velocity of gas, and temperature. So the jet means this high pressure gas, that is the jet. So that means that jet distance and that pressure of the jet, the nozzle geometry, the velocity of the gas, and the temperature are the process variables. Then higher pressure or smaller jet distance produce finer powder. Okay, so the atomization method produces spherical powder particles with relatively smooth surfaces. The powder, because of this atomization method, produces spherical powder particles with relatively smooth surfaces. And this method is suitable for high-speed steel, titanium, superalloys, and reactive metals. The second method is the water atomization. And this method is similar to the gas atomization, and the difference is that here we are using water instead of air jet. In the previous case, that will the jet we are using is air jet, so here we are using water jet instead of air jet. This is the most common of the atomization methods. So there are various types of atomization methods like gas atomization, water atomization, centrifugal atomization, liquid gas atomization, etc. So this method, this water atomization, is the most common method for the atomization methods. And this is suitable for metals having melting point below 1600 degrees Celsius. Here water is coming into direct contact with this hot liquid metal. The cooling is very fast. So here this is the molten metal and this is the water jet, and this water is in direct contact with this hot liquid. So this is the molten metal, this is the hot liquid metal. This water will be in direct contact with this hot liquid metal. The cooling is very fast, but the powder obtained will be having irregular shapes. So in water atomization, the shape of the powder particles will be irregular shape, whereas in the case of gas atomization, the shape of the powder particles will be in spherical shape. And also another important point is the presence of water. The presence of water causes oxidation of the particle surface. So to avoid this oxidation, we are actually replacing this water with a synthetic oil. Okay, to avoid this oxidation, we are actually replacing this water with a synthetic oil. And this method is used for low and high alloy steels, stainless steel, but the particles are irregular in shape. So this point is very important. The particles are irregular in shape, whereas in gas atomization, the particles are in spherical in shape. So in these atomization processes, the particle size of the powder is governed by the velocity of the fluid stream. So the particle size of the powder is governed by the velocity of this fluid stream. So this is the fluid stream, and this velocity of the fluid stream is an important factor that will affect the particle size of the powder. When the velocity of this jet is increased, you will get finer particles. So if you will increase the velocity of this water jet, you will get the finer particles. So this is the second method, water atomization. Then next is the centrifugal atomization. In centrifugal atomization, there are two methods. One is rotating disk method and another one is the rotating electrode process method. In rotating disk method, here the liquid, here this is the molten metal, here you can see this is the molten metal, and here you can see this is the collection chamber, and this is the rotating disk. So here there is a disk, and this disk is rotating. This disk is rotating. Okay. And in this process, the liquid metal is allowed to fall on a disk rotating at a high velocity. So here, this is the molten metal. This will fall. This will fall on a disk. So here, this is the disk, and this disk is rotating with a high velocity. Due to this, because of the centrifugal action, the liquid metal particles are thrown out in all directions. And here you can see on the top of the disk, you can see some dotted lines. This dotted line represents this liquid metal. Because of this rotation, because of the centrifugal action, the liquid metal particles are thrown out in all directions. and the powder particles are collected in the chamber surrounding the disk. Okay, so surrounding the disk you can see the collection chamber, and the powder particles are collected in the chamber surrounding the disk. So this is the first method of centrifugal atomization. And the second method is rotating electrode process. So this is the second method. Here you can see the one figure 1.5 here, rotating electrode process. So this is the rotating consumable alloy bar. This is actually rotating. In the left side you can see a tungsten tip is there, and here an electric arc is established between this rotating consumable alloy bar and this tungsten tip, and because of this you will get the powder. That is the simple working of this. Here the rotating consumable alloy bar is rotating. That's why that technique is called a rotating electrode process. So this is another example of centrifugal atomization. In this method, a solid metal bar is rotated at a faster rate. So this is the solid metal bar, and this is rotating. This solid metal bar is rotated at a faster rate, while one end is melted by an electric arc. Where here you can see the one end of this solid metal bar is melted with the help of an electric arc. The electric arc is established between a tungsten electrode, that is the cathode, and the solid metal bar, that is the anode. So here the electric arc is established between the tungsten electrode and the solid metal bar, that is the cathode and the anode. Okay, so this will be the cathode, and this solid bar will be the anode. Molten metal spins off from the bar and solidifies immediately. So molten metal spins off from the solid metal bar, or that is the anode, and solidifies immediately. And this electrodes, both this tungsten electrode and the solid metal bar, are enclosed in an inert gas chamber, and the powder particles are collected inside the chamber. Okay. So accurate control of the rotation of the anode. Anode means this solid bar. Okay. So the accurate control of rotation is very, very important to obtain proper particle size distribution of the powder. The diameter of the droplet depends on the surface tension of the liquid and the centrifugal force acting on it. So you have to draw these two figures. This is the first figure, and this is the second figure. This is the rotating disk method figure, and this is the rotating electrode process method, that is the centrifugal atomization. And the next atomization is the liquid gas atomization. This process is of recent origin, in which here we are using a cryogenic liquid gas, argon or nitrogen, at a minus 200 degrees Celsius is used to atomize the molten metal. In gas atomization we are actually using gas. In liquid gas atomization we are using cryogenic liquid gas, argon or nitrogen, at a minus 200 degrees Celsius used to atomize the molten metal. The liquid gas kept at 300 bar pressure is used to generate an even stream that will atomizes the melt and cools it rapidly. Upon atomization, the liquid evaporates quickly and the powder is left behind cooled down. Okay, the main difference is we are actually using a cryogenic liquid gas, argon or nitrogen, at minus 200 degrees Celsius is used to atomize the molten metal. Here, what about the cooling rate? Cooling rate is 10 times higher than that of the gas atomization. Okay, because of this cryogenic liquid gas we are using, this cooling rate, when we compare the cooling rate with the gas atomization, here in liquid gas atomization, the cooling rate is 10 times higher than that of the gas atomization. And the purity of the powder obtained is much purer than obtained from other methods, that is from water atomization. So that was about the atomization. So the question is like this: what are the different methods of atomization? So first you have to write gas atomization, then draw these two figures. Okay, this figure. Okay, the figure 1.1 and figure 1. You have to draw these two figures and explain this gas atomization. Okay, explain its working, explain the shape of the powder particles, then explain the process parameters. What about the process parameters, etc. Then the second method is the water atomization. You have to draw this figure, then explain the steps involved in the water atomization process, and what about the shape of the powder particles, and what about the process parameters. You have to explain the process parameters. Then centrifugal atomization, two methods: rotating disk method and rotating electrode process method. You have to draw rotating disk method figure, rotating electrode process method, and explain this centrifugal atomization. And the last one, that is the liquid gas atomization. You have to explain this with the help of this explanation. Here we are using a cryogenic liquid gas at minus 200 degrees Celsius is used to atomize the molten metal. So what is atomization? Atomization means this is the most common method, most popular and most versatile method for the manufacturing of the metal powder. So here this molten metal is converted into fine spray of droplets that will solidifies into smaller particles to form a powder. Any material that can be melted can be made into powder form with the help of this atomization method. Okay, so once again I will show the question paper. Once again I will show the question paper. Okay, so this question is from May 2019. The question is from May 2019. What are the different methods of atomization? Different methods of atomization for making powders, metal powders in powder metallurgy. Okay, so the first step is the first method is the gas atomization. You have to draw the figure, then explain. Then the second method is the water atomization. First is the gas atomization. Second is the water atomization. Draw the figure, explain it. Then the third is the centrifugal atomization, rotating disk method and rotating electrode process method. And the fourth one, that is the liquid gas atomization. Okay, so that's all about this question number 1. And here, whenever you write the answer, please check the mark. So here the marks is 6 marks. Okay, so maybe say we can write 2 marks for or 2 marks for gas atomization, then 2 marks for water atomization, and 1.5 marks for this centrifugal atomization, or half marks for this liquid gas atomization, maybe like that. Okay, so whenever you write this this answer, please consider this marks also. Okay, 6 marks. Okay, when this marks is actually 4 marks, you have to write in such a way that you will get 4 marks. Okay, don't elaborate when the mark will be in 4 marks. Okay, so whenever you write the answer, you please check the marks. Okay, so that's all about the different methods of atomization. Okay, thank you.